So, we have seen what errors and exceptions are in general. So, let us look at more closely at how exceptions are handled in the context of Java. So, remember that all exceptions are treated as objects and they all descend from this class called throwable, which splits into two subclasses. The subclass error, which consists of these JVM related issues. These are issues with the resources and all that of the underlying runtime, which you really have no control over. So, in some sense, this is not the programmer's fault. And the other side, you have exception, right. So, two subclasses are error and exception. Under exception, again, you have two groups. The first group is called runtime exception, and runtime exception corresponds to errors which occur in the code because the values are kind of globally wrong. In some sense, you are trying to access an array which is outside the index range, or you are trying to access a key in a hash table which is not present. So, these are things ideally in your code you should be defensive, as they say. You should say if I is less than 0 or I is beyond the array length minus 1, then you should not try to access it, but rather flag the error. So, ideally these runtime exceptions should be caught by your code and not by the underlying system and flagged as an error. On the other side, you could actually have these checked exceptions, which are peculiar to the logic of your code. You do not want to store negative numbers in a list, then whenever a negative number comes, you can say this is illegal and give a suitable error message. Right? So, now what we want to see is how we do all this in Java. So, at the first level, let us look at the side of calling code which has errors. Right? So, this is there in Python also. So, you have this try statement. So, whenever you are going to call code which potentially might create an error, you call it with this try. Right. So, there is this try block, and in that try block you put the call to the function which might throw an exception, and then if an exception actually occurs, it will abort the try block and look for a catch block which matches it. Right. So, here we have a catch block which goes with the try block, and this is the handler. Right. So, this is the code that deals with the exception. So, it is like a function in some sense. It gets the exception that was caught in some sense by the try, which was generated by the try code, and then it tries to do something. So, you can examine that exception and do something to handle it. So, Python also has a similar structure. So, this should be reasonably familiar to you. So, the usual thing happens, which is that if try encounters an exception, then whatever, so if the exception happens here, then these statements beyond that are not executed. You just skip that block and move to the corresponding catch. Hopefully, there is a catch, right. So, if you match this, if the exception that you got, so notice that this has a type, right. The catch is now looking for an exception which belongs to a particular type. So, if you match the type, then the corresponding block is triggered, right. Otherwise, if there is no matching catch, then this exception is as though it happened without a try, right. So, you were trying to catch an exception, but not this one. You had no awareness of this one. So, it is as though you did not try to catch it at all. So, it gets passed back to the caller, right. The function that called you now gets the exception that you generated by calling a third function. So, F calls G calls H generates an error, it passes back to G does not know what to do with it because it does not catch it explicitly, it goes back to F. And as we said, if this happens all the way up, like F does not know what to do, it passes back to E and so on. At some point we started the computation typically with our main, right. So, then eventually if the error goes back all the way to main and main has no way to handle it, then the program will crash and the user of the program will see an error message on the screen saying something bad happened. Okay. So, this is the extreme case of what happens when these errors happen, but ideally we would like to catch it and take some action against it, right. So, what we saw is that we want to match the exception and catch it, but there may be multiple types of errors. So, the good thing is that you can have multiple catch associated with one try, because this code might generate many different types of exceptions and you might have to take different corrective action depending on the type of exception, right. So, you have several catch blocks here and each of them catches a different type of exception. So, this is like our function signature, right. So, we have the same name, all of them are called catch, but they have different argument types. So, based on the argument type, the appropriate one is chosen, right. So, just like in other functions, right, this argument type is compatible with the hierarchy. So, if you have something which is of, if you have a catch whose argument is expected to be of some class exception type, then there may be many different subclasses of that type. Any one of them will work, right? So in Java, for instance, IO exception is actually a built-in exception class, and file not found exception is a particular case of an IO exception. So if you are expecting an IO exception, it is okay to get a file not found exception, right? The usual thing. If you are expecting the superclass, you are okay to get an object of the subclass. There is no type error. So that's exactly what happens in catch. So then we have to disambiguate as to which catch is actually going to be used, because the same argument may match different argument, I mean the same exception that comes may match different argument types because of this compatibility of this hierarchy with the object hierarchy, right. So what happens in Java and even in Python is that these catch blocks are actually tried in sequence. So you first try to see if E matches file not found. If it does not match file not found, then you check whether it's an unknown host exception. If it does not match unknown host exception, then you check for an IO exception, right. So it goes in sequence, and the first one that matches is the one that is executed. Now in particular, this means that you must make sure that you must go from more specific to less specific. So as I said, file not found exception is a subclass of IO exception. So supposing this one had come on top, then if I actually got a file not found exception, it would match IO exception, and the IO exception code would trigger. So it would not reach the code which is specifically meant for file not found exception. So you must go from more specific subclasses to higher superclasses. So in some sense, as you go down, it becomes more and more generic, the kind of exception that you are trying to handle. So let's look from the other side now, right. So we saw we will come back to this thing in more detail, but we saw how you would catch an exception if the code that you are trying to execute generates an exception. So how does code generate an exception, right? So as we said before, there is this exception error of type, exception of type capital E error, which is a Java runtime issue, and this is something which happens because of some resource issues within the runtime, and you can't do much about it. Then you have a runtime exception, okay, and runtime exception we said are typically issues with coding, like you try to access an array out of bounds and so on, and this is something that ideally your code should try to check and catch. Now you might call another function which generates an exception and you don't handle it, so then your code generates an exception, right. So you are not generating the exception in your code directly, but indirectly. You call F calls G, G generates an error, so implicitly F generates an error because F does not have a try catch for it, right. And the fourth case is when you actually detect something anomalous, something wrong happening in your code, and you choose to generate an exception. So this is the checked exception case where you want to throw something explicitly, right. So these are the typical situations in which a function might generate an exception. Either it happens because at runtime something went wrong, or it called a function which generated an exception and it did not catch it, or it voluntarily decided to throw a checked exception. So let's look at these checked exceptions, right. So supposing you are trying to read some data from some source, and maybe one of the data items, the first line of the data item tells you something about how much data there is, right. So this typically happens, for instance, when web browsers read web pages, right. So there is usually a content header, as it's called, which tells you how long the web page is, how many bytes the web page is. So supposing the first line tells you that it should be 2048 bytes, right, and now you actually read the text and the file or the text ends before 2048 bytes. So you get less than the promised length. Now you could ignore this and go ahead, or you could say that there is a mismatch, right. There is something that was promised and something that you got which was not correct. So you want to do something about this, right. So now you want to throw an error. So the first thing is what type of error to throw, right. So the simplest thing is to try and throw an error which is already present in the Java library of exceptions. So if you search through the Java documentation, then you find that there is an exception called end of file exception, EOF exception, right, and this is a subtype of this IO exception that we talked about in the previous example. So what does an EOF exception do? According to the Java documentation, it signals that end of file has been reached unexpectedly during the input, which is pretty much what has happened here, because you were looking for 2048 bytes and you unexpectedly discovered the end of the input before that. So this seems like a reasonable thing to do, to throw this exception. So now this is an exception class. So remember that an exception itself is an object. So what you do is you create a new object of this type and throw it. You say throw, so throw is the command, and the argument that you pass the command is a new exception object, new EO of exception. So of course you could also do it separately. You could say EO of exception, you could create this thing, right? EO of exception E is equal to new blah blah blah, and then you can say throw E, right? So you can do it in two steps, right? To first create the exception object and then throw that created object, or as in this case, you are implicitly creating and throwing an object anonymously because you don't really need the name. You are just making an object of this type and then passing it back. So this is the simplest form of constructor which is available for all these exception objects inside Java. You can also provide this exception object with a message, right? So you might want to declare why you are creating this EOF exception. So you might create a message which says the content length was so much and I received only so much, right? So you can construct a string which signifies the details of the error that you actually want to report, and then you can create this now new exception object by passing this error message as a parameter. So when you create an exception object, you can either create it with no parameter, so it just produces a kind of empty object which just says this is what happened, and from the type of object you can try to decide what error it was, or you can provide a string as a diagnostic which tells you in addition to the type of object what was the specific context in which this error was generated. So we said before that it is okay to generate an exception inside a function, but how does the caller know about it? Because the caller also has to take action based on whether or not a function can provide an error back. If I call a function and I am not aware that this function might generate an error, then I might not be able to take, first of all, I may not be able to take suitable action because I don't know what kind of error is going to generate. But secondly, my code which I believe was robust might crash for reasons which I don't know, right? So for many reasons, it is not good for a function to generate an exception without the other functions that use it being aware of it. So what Java insists is that you must indicate in the header of the function any exceptions that you explicitly throw, right? So if in your code you have this, that you throw a new EOF exception with this error message because you got less than the expected amount of data, then you must say upfront that I am capable of throwing an EOF exception as one of the valid behaviors of my code, right? So if everything goes well, I will give you back a string, but if things do not go well, I might instead give you an EOF exception. So this has to be declared. Now you can throw more than one type of exception. You don't have to, just like we can catch more than one type of exception in one try statement, you can also generate at different points, different things may go wrong, right? So you might be reading from a file and the file may not be there. You might be trying to read the file and it might end up having fewer bytes than you expected. So you could throw, for instance, both of, depending on the context, a file not found exception or an EOF exception. So you can give a sequence of exception types in the header separated by commas to indicate that these are all the types of exceptions which I am capable of throwing. Now, just like arguments are compatible with the hierarchy, so is this header which throws, right? So when I say throws IO exception, what I mean is it can throw IO exception, but it can also throw anything which is a subclass of IO exception. So if I say that it throws IO exception, then the code that receives this exception should be prepared for something which is either an IO exception or a subclass of it. So if I can generate a file not found exception, I can generate an EOF exception because both of these are actually subclasses of IO exception, right? So both while catching an error where I use the class hierarchy and I can get a more specific error for a more generic argument type, and when throwing a thing I can advertise a more generic error type and throw a more specific one, right? So the class hierarchy is kind of the way that the class hierarchy interacts with arguments is uniform in this error handling and exception handling as it is when functions are called in normal things. So the method now has declared it. Now the flip side of this is as you call the method, you must handle it, right? So this is something now for the compiler. So Java, as we have seen before, tries to make as many things visible at compile time as possible. So as many inconsistencies as possible should be flagged at compile time and not when the code is running. So if you call this function, right, then you know that this function has this EOF exception as a possibility. So then it is your obligation to handle it. So what does handling it mean? Handling it means that you must have a try block for it. If you do not have a try block, what we said is that this function will now pass this error back to the calling function. So implicitly your function also throws an EOF exception. So you have two choices, right? I call this function read data. Either I do a try read data and catch this exception and do something with it, or I do not do a try, but then it is possible because read data generates EOF exception that this code generates EOF exception. Then in my header I must say that it is also possible that I throw an EOF exception because I sort of pick it up from a function that I am calling whose exception I am not handling. So this is now something that the Java compiler actually enforces. So if you do not do one of these two things, either catch it or declare it as a throwable exception from your function, then Java will say that there is a compilation problem with this function code. So there are some sort of exceptions to say use a common word. So there are some exceptions to this rule. So in particular, if the code that you generate, code that you call creates an error or a runtime exception, right, then as we said, these are things which are happening because of some execution time problems, and it is not your responsibility to catch these, right. So if the person who wrote the code was sloppy and they did not check an array out of bounds, you are not obliged to report it. So if you are only calling checked exceptions, then you have to report it. So you have to either catch it or you have to report it by saying that it is also a checked exception for my header. But if it is an error or a runtime exception, so that is why these are called unchecked, right. So Java's compiler does not actually check for these exceptions in the code. So just to highlight, you should not normally generate this, right. So it may be generated because of sloppy code. Right? The person forgot to check it and therefore at runtime the program crashes and it generates a runtime exception on its own. But it is not good practice for you as a programmer to say, oh, I is bigger than n and therefore I will generate a runtime exception. If you have detected that I is bigger than the length of the array, then you should provide a better exception than that. So you should provide a checked exception which explains what happened, right. So don't rely on untimed exceptions. If you runtime exceptions, if you have a runtime exception that you are checking for, then please generate some exception which is more meaningful than just the runtime exception. So the calling code knows what to do with it. So also the calling code is aware that you are checking for this. Okay? So checked exceptions typically arise in specialized circumstances, as we said, when you have some code which has some constraints which are not part of the normal data structure constraint. So we have a linear list, for instance, which stores some order numbers and we do not want any negative numbers in this. Now there is no negative, non-negative integer type which will generate an automatic runtime exception. So we have to do something about this. So in order to flag this, we have to first create a customized exception class, right. So we will perhaps call it negative exception. So everything that we want to generate must sit under throwable, and in particular it must sit under exception, because remember that throwable splits as error and exception. So if we extend the exception class, then we get automatically all the default functions and all that which are defined in that hierarchy up to exception. So in this class what we have said is that we will store the error, the offending error. So this happens because somebody tried to insert a negative number into our linear list which does not like negative numbers. So we will store that thing. So when we construct an exception of this type, right, there are two things. One is the message that is to be printed to the user, and the other thing is this information about what negative number created it, right. So what we can now do is, in order to get this error to actually incorporate this message, we just call the super type constructor, the constructor associated with our negative exception, and we put this message there, right. And then because we have this information here, we set this error value to be -1, or not -1, to be I, the value that you created, right. And now we might add a public function which reports this error value. So these are now, because this class is going to be usable like any other class. So if somebody gets this particular exception, then they can look at the public methods and say, oh, this is the exception. I can actually find out what was the mistake by looking up this report error value function. And now when I define my linear list class, right, I would define in the add where I add an element to the linear list, I would define that when I is negative, it throws a new negative exception. So, this is the message that the error would generate, negative input, and this information, if you remember, gets stored inside as a private integer, which is exposed through that public method, which allows you to retrieve the offending field. Now, the other thing to note is that because I am now throwing this negative exception, I have to advertise it, right. So, therefore, this add function now has an extra component to its header, which says that it throws a negative exception. So, if I am now at the other side and I get this negative exception, right, then I might want to find out about it. So, the most basic thing I can do is to get the error string associated in that message. So, this is defined in throwable itself. So, the highest level in this error hierarchy is throwable. So, it has some default functions defined. So, one of them is get message. So, you can always extract the error message associated with an error by using this get message. So, remember that you get this as an object. So, then you can invoke this, and this is of an exception type. So, it will always be compatible with the throwable type. Now, the other thing that you can do is to take an error of one type and pass it on as an error of another type, right. So, supposing you have some code which is trying to access a database, right. Now, you have written some kind of a server application, a servlet as it is called, right. So, you get in your code some error from the database which is of type SQL exception. So, what you want to say is that this SQL exception that I received from the backend from the database, I am going to pass on as a servlet exception to the function that called me. So, I am going to throw a new servlet exception, and in this new servlet exception, I am going to pass on the message that I got from the database, right. So, I add this string database error, and then I pass whatever message I got back, so that the servlet exception carries in some sense some history about where it came from, right. So, this is why it is called chaining. I am taking one exception and kind of passing it on with some extra information involved. Now, you can do a little bit better than this, right. So, you can actually do more than just pass on this message, right. So, right now what we are saying is we are passing on this message, but we do not have access to this E anymore, right. This E, the only thing that the code that we wrote here did was it extracted the message that E provided and stuck it into a new error. So, the new error only has that error message, it does not have any further diagnostic information that came from the SQL database. But logically, if I know that the error came from the SQL database, I might want to know that error as well, not just the error that has been generated in this servlet. I want to know more about the SQL exception, right. So, then throwable has this thing called get cause and init cause. So, what I can do now is I can make this a little bit more refined. I can first set up this error message, right. Then I can create this new error object, which is a servlet exception to the error message, and now I can add some extra information to it through this init cause. I can say that the initial cause of this new error is this old error E, right. So, this should be throw new E, sorry, right. So, I got an error E from which I built a new error new E. So, I record in new E, it is like a linked list in some sense of errors, right. So, I have an error which is a servlet error, and it points through this cause thing to the error that generated it. So, I have hidden inside, right. So, this is this chaining. So, it is like a list or it is like a nested box. So, the box servlet error contains inside it the SQL error. So, any information I want about the SQL error I can now extract, because on the other side, right, I can get the servlet exception and it has an E, right, it is the outer box. I can get the inner box by calling the corresponding get cause, right. So, init cause was used to create the inner box. Now, get cause extracts that inner box. So, now the function that called the servlet can now look one level deeper into the SQL error and find out everything about it, right. So, this is this idea of chaining. So, you can kind of nest the errors once inside the other as you pass them up. So, at the top level you can go down as many. So, in particular if the SQL error itself had another error, right, then I can look at original dot get cause and find out whether the SQL error itself was generated by one more error. Eventually, when you get to the bottommost error, as you would expect, this get cause will be null. So when you find that the get cause is null, you know that this was the original error in some sense, right? This was the source of all the errors, but till that you can keep following. It's like following links in a linked list. You can keep going get cause, get cause, get cause until you hit null. So you get all the errors on the chain that generated this error, right? So this is chaining errors. Another thing that we have to be careful about is what happens when we abort code due to a try. So that when an exception occurs, we said the rest of the try block is skipped, and this problem might arise that the rest of the try block might be doing something which you need to do, like you might want to close a file, right? Or you might do something else, you might want to delete some node in a list or something like that, right? Which you expected to do, but it did not happen because your try block aborted in the middle. So what you can now do is add an extra special block at the end called finally. So finally has a property that it will always be executed, right? So it will be executed whether or not you come through, whether the try terminates normally or it terminates exceptionally, right? So there is no way to bypass the finally. So whichever way you come through this, either you come through here or you come through here or you come through here, all of these will eventually hit finally. So just to understand exactly what it means, so let's look at this more elaborate thing, right? So we have here code which initially opens some file input stream, right? And finally it's supposed to close it. So it tries something with this file input stream which might throw some exceptions, right? And one of them is an IO exception, and in this finally block now we have put this close. So we don't want to put the close here because it might get skipped, right? So we put the finally block here. So what are the different things that could happen? So the first thing that can happen, of course, is there is no error, right? So if there is no error, then I come through this block unscathed, right? And at this point I go over to the finally. So I do 1, 2, then I do 5 and then I do 6, right? So 6 is the code after this. So basically one of the properties of the try block is it does not abort as such unless the error is propagated uncaught. So if anything happens inside and the error is caught, it will go to the next statement. So 6 will happen after this try block is finished, but it will execute 1, 2 and 5, 1 and 2 from the try block and 5 from the initial, from the finally, right? So this is what happens if there is no error. Now the next possibility is that there will be an error here which will take it here, right? But this actually goes through fully with no further error being propagated. So then what happens is that I do 1 and then I hit an error in that code which might throw an exception. So that throws me to 3, but 3 goes after to the end of its thing without doing anything. And then from here I come to the finally. So then I do 5 and 6. So I do 1, 3, 5 and 6. So the only thing that gets skipped is this 2 which was in the try. But there is a third possibility, and the third possibility is that in this itself some error happens, right, which I did not anticipate. So this might be an error which takes me, I might throw another exception for instance, right. So you might think that when you throw an exception inside a catch that you get out of it immediately, but you don't, right. So supposing you have a chained exception like we saw it earlier, right, the SQL error decided to throw an servlet error. Even then you will come into the finally. So if I have, say for instance somewhere here, if I chain an error, then I will do 1, then I will come here, then I will do 3, right, and then when I show an error message I might simultaneously throw a new chained error message, but I will still come to 5, right. But now because I have thrown an exception, I am not going to continue with this code anymore because I have effectively said go away, right. So I have thrown an exception. In the other two cases I handled the exception, so I proceeded to the 6th block. Here I have thrown an exception, but before I go away I will still execute the finally, right. So the finally will always be executed. Whether or not you continue after the finally depends on whether you threw another exception or not. So I hope that clarifies exactly what happens with the finally block. So to summarize, we have this try catch mechanism which is there also in Python to safely call a function that may generate errors. So you try to execute the code and you can use multiple catch statements to catch the different types of errors that the code may throw. And on the other side, you can throw an exception which is usually a checked exception. So if you detect something anomalous when the code is running, you can freely throw it, but when you throw it, you must advertise it, right. So Java insists that code which generates exceptions must have it in the header. And this serves two purposes. One is from a kind of socially useful point of view, which is that the programmers who call your function must be aware of this. They should not accidentally crash their code because you crashed the code. But the other thing is that Java actually now uses this to compare the code that is calling your code with the code that you have defined. So Java's compiler will enforce that the code which calls such a function which throws a checked exception actually either handles that exception or explicitly passes it back as a checked exception of its own. Right? So Java actually does a compile time check of compatibility between calls and definitions of functions that throw exceptions. So exceptions are complex objects. So we can look at them and get information about them, and we can put information into them also. Right? So we saw that negative exception in which we stored as a private variable the negative number which generated the exception, which we could then extract through a public function like a get function which caught it, or we could have this get cause kind of thing which gives us a chain of exceptions. So we can therefore use this exception object structure in order to encode a fairly rich amount of information about this exception and whatever triggered it, so that the code that gets the exception back is able to examine this and take appropriate action. And in order to deal with this problem of code which should have got executed but did not, typically to do with resource allocation, files being closed and all that, we have this extra finally block which comes at the end of a try, which is always executed no matter how the try ends, whether the try is normal, whether the exception happens, the exception is handled properly, the exception throws a chained exception. All these cases, the finally will definitely be executed.